Okay, this will be lesson 2. We'll call it reflections. So as I said in the opening, the reflection is like a flip over a line, okay? And that line is called the line of reflection. Okay? Now, by definition, a reflection is where each point and its image are the same distance from the line of reflection. Okay, so possible lines of reflection, most obvious ones are the x-axis or the y-axis. They could also be just plain vertical or horizontal lines. So those equations are x equals some number or y equals some number. Okay, so just as a quick review, x equals is going to be a vertical line. Y equals is going to be a horizontal line through that number that is given there. All right, so let's see how this works. So we're given this triangle, and they want us to reflect it in the x-axis. So the first thing we want to do is find the x-axis. So I strongly encourage you to either take a highlighter or a colored pencil like this. I usually just wiggle it going across there. That is my line of reflection. All right. Once I have that, then it's just counting. Remember up here it said that each point is the same distance from that line of reflection. So that means the reflection of this point is the same distance from the orange, okay, as its new one. So to go from here to the line is 1. Reflection's going to be 1. Right there. Okay, I guess I don't have any points on here. A, B, C. So this right here, I reflected the C, so this is C prime. Okay, let's go here and do B. So count to the line. 1, 2, 3, 4, 5, 6, 7. And then count again. 1, 2, 3, 4, 5, 6, 7. By doing that, you are assuring that both the points B and B prime are the same distance from that line of reflection. Do the same thing with A. I go 1, 2, 1, 2. There's my new point. Connect A, B, and C. And I have reflected triangle ABC over the x-axis. Done. It's not too bad, is it? The hardest part will be find the line of reflection. We're not going to worry about points. You can obviously identify them just by finding the ordered pair for A, B, and C prime. There are some formulas that can be learned that will help you get those ordered pairs without looking at a graph. We're not going to worry about that. Triangle RQ, PQ, RS. There's the 4 points. This time we want to reflect in the y-axis. Okay, so the y-axis is this vertical one that goes up and down. So, like I said, I just kind of swiggle it across there. You don't have to. You can use a pencil to kind of highlight that line. It just helps tremendously because then you don't have to like refigure out where you're at. So this time we're going to always take all the points here and we're going to count to the line. Obviously, we have to go to the left. So let's do the farthest one away. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's 8 on each side. So here is R prime. So the farthest one away from the line here is the farthest one away from the line over on this side. Okay, S is going here. We're going to count to 7. Count to 7. So there's my S prime. P is easy. 1, 1. There's P. And Q is going to be just 2. And 2 more. There's my Q. And there's my new image. Done. We've done our reflection of this rectangle in the y-axis. I've flipped it over that line. The closest ones are still the closest ones. Okay, if you remember with translations, they just slid. So whatever was there is no longer the same distance as it was before, okay? Now, on these bottom two, you can see here we're going to reflect over x equals -1. Okay, this again will be the hardest part for most of you, is making sure you get that right line. So x equals -1. I start in the middle, here's my x, here's my -1. So it's going to go through that point at -1. Okay, so there's my line of reflection. Once you have found that and located that, then it's the same exact rules as what we just did in the first two. We're going to do count to the line, so 1, 1, here's my new r. The s is going to be 1, 2, 3, 4, 5, 6. Okay, then we have to go 6 more, which will get me right there. Okay, did everybody see what I did there? You don't stop at the y-axis. You keep on going to the dotted line. Okay, so that's going to be my new s. My u, I'm going to count to the line again. 1, 2, 1, 2. And obviously, it doesn't matter which ones you start with. So I'm going to go here. T is going to go, oh, there's 6, 7 to the line, and 7 again gets me way out here. So the farthest one away from the line is still the farthest one away. And our last one, y equals 2. Again, you're going to find with the y equals 2, that is going to be a line like this, a horizontal line that's going to pass through positive 2. Here's where I start, here's my y, I count up to the positive 2, and then this is my line of reflection. From there, I'm going to count to the line. So I'll just do C first, this farthest out one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's my new C, C prime. So the farthest one away is going to be the farthest one away, because they have to be the same distance to this line of reflection. 3, 4, 5. 1, 2, 3, 4, 5. There's my new F. E is just going to be 1, 1. And D here is 1, 2, 1, 2. Okay. Again, you'll see that the shapes have not got, whoops, that's a bad line. The shapes have not changed. They are the same size, same shape. They are in a different orientation now, but they are called rigid. They are not changing shape or size. They're just moving to a different location in a different orientation. So that is reflection. If you have any questions, especially about where are those lines of reflections, please let us know.